Hello, in this video we're going to look at how to take a proportion and create an equation, a table, and a graph from that situation. So let's really quickly look at what a proportion is just to make sure that you remember. So a proportion is an equation that is stating that two ratios are equal. So let's look at two examples of that. Our first example here is 12/15 equals 16/20. So this is saying that this fraction equals this fraction. Let's make sure that works. So if I do 12 divided by 15 in my calculator or in my head, if I remember what that is going to be 8/10. Then if I take 16/20 and do 16 divided by 20 in my calculator, I'm going to again get 8/10. And you can check in your calculator to make sure that that works and make sure that you know how to do that too. I also have over here what that would look like as an x and y table. So I have my x of 15, my y of 12, x of 20, y of 16. So you have these two ordered pairs that are proportional here. If I look at this next example, this says I have 120 miles in 3 hours and 160 miles in 4 hours. So again, I'm saying that this fraction equals this fraction. And when I divide 120 divided by 3, so I took those 120 miles and I divided it into 3 equal hours, I got 40 miles every 1 hour. And then I did the same thing over here. 160 miles divided into 4 hours meant I had 40 miles every 1 hour, so they were equal. Both of these cases, I was going 40 miles in 1 hour. And again, I have this as a x and y table too, just so you can see what that looks like. Now let's look at how you would turn all of that into tables, graphs, and all kinds of fun stuff. So I'm going to look at the four corners activity. And I have a situation here. My verbal is Tanner cycled, or he was riding a bicycle, we could say 8 miles in 20 minutes. What is the constant of proportionality based on this situation? So I'm going to look at, in my table here for this station, gave me a little bit of information here. My table said that my time was on the top here in minutes and my distance was on the bottom in miles. So since in this case, the distance that he's going depends on the time that he is traveling, my dependent or y variable is distance, then time would be my independent variable, and that's x. So if you remember to get your constant of proportionality, it's always going to be y divided by x. So in this case, my y is miles, so 20 divided by minutes, or 8 miles over 20 minutes. When I divide 8 divided by 20, I get k equals 4/10. So that means if I'm going 8 miles every 20 minutes, I'm going 4/10 of a mile every 1 minute. So that is my constant of proportionality, or unit rate, if we want to call it that. So we're going to use that information to come up with our equation. Again, x, time in minutes, y, distance in miles. So I'm going to use my same proportional relationship equation, y equals kx. So therefore, y equals 4/10 x. And I just got that right from here. I plugged it right into that equation. Now I'm going to go ahead and finish the table that was started for me. So using that equation that we just came up with, y equals 4/10 x, that means whatever time I'm given, I'm going to plug that in for x, multiply it by 4/10, and that's going to get me my y. So in this case, 2 minutes, I'm going to take 4/10 times 2 and get 8/10 of a mile. If I have 5 minutes, I'm going to do 4/10 times 5 and get 2 miles. I'm going to do 10 next because that one is the easier one. 10 times 4/10, if I do 4/10 times 10, I get 4 miles. Now, this other one is a little trickier. It gave us 3 2/10, and we needed to find out the time. And that one is actually we can use, if you remember, solving one-step equations. So I'm plugging in 3.2 into my equation for y, and I have 4/10 x left. Since I need to know 4/10 times what gives me 3.2, I'm going to do the opposite of multiplication, which is division, and I'm going to divide by 4/10. So 3.2 divided by 4/10 actually is going to give me 8. So my last table to fill in there would be 8. Then the last piece is creating the graph. We always want to label our x-axis. In this case, it's time in minutes, distance in miles. And then we can go ahead and just plot the points that we have right here. We could plot different ones if we wanted to, but I plotted 2, 5, 8, and 10 for my x, and the y variables that went with that. So for 2, that was 8/10. 5, I went up to 2. For 8, I went up to 3.2, and for 10, I went up to 4. So that's how you represent that situation in an equation, a table, and a graph. Thank you.